Hi everyone, I am Suchithra, working as an assistant professor in the Department of Artificial Intelligence and Data Science in SNS College of Engineering. Now we are going to see the topic of types of normalization in business intelligence and analytics. Okay, in previous video we have seen what is normalization, what are the advantages. In this video we are going to see about the normalization types. The first type is first normal form, that is first NF. Next one is second normal form, third normal form, Boy's code normal form, fourth normal form and fifth normal form. We will see each one in detail. First normal form, that is 1NF. The first normal form requires that a relation contain only atomic values. Atomic values are indivisible and cannot be further broken down. This means that each attribute in a table should hold a single value and cannot contain multiple values. This initial level of normalization focuses on a fundamental structures of table. In 1NF, each individual cell within a table should hold a solitary value and each column must possess a distinct and unique name. The primary objective of achieving the first normal form is to eradicate duplicate data entries and streamline equal process. We'll see the example. Each cell in the table should contain only one single value. Column should have unique names. For example, student ID, course ID, course instructor, course location, instructor officer. Each cell in a table should contain only single value. It should have single value. That is, the student ID must be 101 and 101. The column should have unique names. That is, the course ID and course instructor and course location, instructor officer, that have this is the column and the row have the different values. To bring this to first NF, you should split the table into separate tables for students, courses and instructor. Now we will see the second normal form. To meet the requirement of second normal form, 2NF, a relation must be in 1NF and all non-key attributes must have fully functionally depend on a primary key. This means that each non-key attribute should depend on the entire primary key and not just a part of it. 2NF addresses the issue of redundant data by establishing a requirement that each non-key attribute must rely solely on the primary key of its extensions. This dictates that each column should directly correlate to the primary key and not derive dependency from the other column. We'll see the example. Non-key attributes should be fully dependent on a primary key. Here student ID, course instructor, course location, instructor office. The student ID is same, course ID is different and the course instructor and course location and course function. Assuming student ID, course ID is a primary key. Here we are assuming that course ID and student ID is primary key. Course instructor and course location and instructor office depend only on course ID, violating 2NF. To achieve 2NF, you didn't split the table into students, courses and instructor. Now we will see the third normal form. A relation is said to be 3NF if it is in 2NF and non-transitive dependencies exist. Transitive dependencies occur when an attribute depends on another attribute through a third attribute. By eliminating transitive dependency, data redundancy is reduced and the database is better organized. Building upon its principles of 2NF, 3NF takes a step further by mandating that all non-key attributes remain independent of one another. This stipulation necessitates that each column maintain a direct association with a primary key and should not establish dependency on other columns existing within the same table. We'll see the example. Non-key attributes should not depend on the non-key attributes. Other non-key attributes. Student ID, course ID, as same example is given. Here, instructor office depend only a course instructor and non and course ID. To achieve 3NF, you split the table in students, courses, instructor and locations. The next one is Boys Code Normal Form, BCNF. Boys Code Normal Form is a stronger version of 3NF. A relation is in BCNF if it is in 3NF, and every determinant is a candidate key. In another word, there should no non-trivial dependency between attributes in the table. BCNF represents a normal stringent extension of 3NF guidelines. If it ensures that each determinant with a table function as a potential candidate key. In simple terms, BCNF guarantees that every non-key attribute derives its significance exclusively from the candidate key, not any other attributes. We'll see the example for that. That's the same example. It's the variation what we have given here. We can see every determinant attribute that determines other attribute should be a candidate key. As the same, here we are taking the student ID, course ID and a course instructor. Here course instructor depend only on course ID, which is a candidate key. This satisfy the BCNF. Fourth normal form, 4NF. A relation in a fourth normal form, if it is a